To begin from here, open the scene called scene7.hip. In this part, I will talk briefly about how Mantra's render engines work, so you will be able to understand better what's happening, and it will become easier for you to know which renderer and which parameters to choose. Let me begin by explaining the concept of refining and dicing. The idea behind this algorithm is that instead of tackling a big problem, the problem is divided into smaller problems, and then each one is tackled alone, so it will be easier to solve. What does that mean when rendering? Well, Mantra has the ability to refine the geometry. So whenever needed, it will keep splitting this geometry into smaller primitives until a primitive is small enough to dice into a grid of micropolygons. You may ask, what are micropolygons? Well, micropolygons are by default polygons about the size of 1 pixel, but you can ask to make them bigger or smaller if you need to. I will show you how to do that later. Now that you know what refining and dicing are, you should know that not only the micropolygon engine does that, but the ray tracer also. Though the main difference is that the micropolygon engine dices everything, while the ray tracer dices the geometry if it doesn't know how to ray trace it natively, like NURBS, subdivisions, or displacements, for example. I told you before, you can specify the level of dicing you need. Let me show you where you can do that. If I go into any of my objects, I'll select this teapot, for example, and then I will go to this dicing tab here. Here you can see two parameters. The shading quality defines the level of dicing if you are using the micropolygon engine, and the ray shading quality defines it whenever using the ray tracer. One important thing to mention here is that the micropolygon engine can be a hybrid engine, and what I mean by that is that by default it will render as micropolygon engine. But if any shader in the scene calls for a function that needs ray tracing, like if you have a reflective material, it will then do ray tracing for that object. And that's why you can obtain reflections, for example, even if you are rendering with the micropolygon engine. Now, after the phase of refining and dicing comes the phase of calculating the colors of the pixels. So let me begin with the micropolygon engine. Here, the corresponding shader of a micropolygon will be evaluated 4 times. 1 for each corner. Then random samples are taken on that micropolygon. The number of those samples is defined by, let me show you here, I will go to my out context, and then I will go to this sampling tab. So the number of samples is defined with this parameter here, the pixel samples X and the pixel samples Y. The result of each sample will be an interpolation between the results we've got for the 4 corners. Unless, if you do not want for this interpolation to happen, let me show you how you can stop that from happening. I'll just go to Edit Parameter Interface for my object, and here I will search for Smooth, and you can see this smooth grid colors here. I'll just add it, I'll hit Accept, and here if I go to Shading, you can see it here. So all you have to do is turn it off, and in such case, no interpolation will take place, and it will always use the bottom left corner result. After all the sampling is done, the average of the samples is taken, then filtered, using a Gaussian 2-2 filter by default. Let me show you where is that default. I'll go to my out context, and in my Mantra node, I will go to the output, and here you can see Gaussian 2-2. So the samples are then averaged and filtered using the filter you use here, which is by default Gaussian 2-2, and then we get the result for the pixel. That is for the micropolygon engine. Now for the ray tracer, after the refining and dicing phase if needed, the engine will send a number of samples for each pixel. That number being defined by the pixel samples, which are the same as for micropolygon engine, and you can find here. Then for each sample, the shader will be evaluated and the samples are averaged and filtered just like before. The PBR engine uses either the micropolygon or ray trace engine, so it works mostly similarly regarding the matters we discussed, except for some differences. And one very important difference is that for each sample, it chooses one light at random and samples its direct lighting contribution, unlike the other 2 engines which take into account all the light contributions. And that draws our attention to another issue here. It is that the PBR engine needs more samples. So it runs the shader many times, controlled by the maximum ray samples you can see if we go down here. One other difference is that the PBR engine automatically enables things like ray traced shadows, reflections, refractions, etc. Now, let me tell you a little bit about the irradiance caching, which can help to reduce render times dramatically, and in some cases, it helps also getting rid of the high frequency noise. So where you can find irradiance caching, I'll go up a little bit, and there's here this tab called irradiance caching. In fact, what irradiance caching does is whenever you have irradiance calculations in your scene, like if you are using the Vex Global Illumination for example, it will use samples from the neighboring pixels instead of calculating all the samples. This way, less samples are calculated, thus less render time, and it smooths out the result. This irradiance adder here, let me enable the irradiance cache, this irradiance adder parameter here defines the acceptable adder. So the smaller the value, the more the samples, and the more the render time, but the result will be more accurate. Then, those minimum and maximum spacing define the minimum and maximum radiuses inside which you will search for pre-calculated samples. There is also other parameters that you can add for this irradiance tab. Let me just right-click on my render node and edit parameter interface, and under the for rendering, I will type irradiance, and I will add all this folder. So I will install parameters, I'll hit accept, and now you can see a bunch of new parameters appeared here. Maybe the most important of those is this irradiance cache file here that you can use to save the irradiance to a file once it's calculated. Those were the main things I wanted to talk about in this part. I hope I was not very technical. Now let us use some of this information to get our render done.